and welcome back to Element 14 Presents. I'm Maria and today I'll build with you a smartboard for your kitchen. I don't know if you ever had this problem, but since we are living up alone, me and my boyfriend keep forgetting about the food in our fridge. That is the case of poor Mr. Tangerine that should have been eaten a lot of time ago. So my idea is basically to building a shopping list that actually reminds you when the food is about to expire. Basically, I want to keep a whiteboard that I bought in the center, then add here some LEDs, okay, and here, okay, and some buttons near the LEDs, okay, like this. Then it will have a screen here and some buttons, okay, this is an OK button. So that the LED can light up in that it was my alarm, can light up in brightful colors like red when the food is about to expire, like the day after, or maybe green if the food has already some days, as more than 1 day to live. Okay. And you can select the entry, like, I don't know, fish here with the button, and then set the date to the screen. Then it will have like a photo sensor here, so when you wave at it, it wakes up and it like switch on the screen, and okay, it's nice. Let's see how the LCD works. I'll test it on a breadboard with an Arduino Nano. I'm going to follow the official Arduino tutorial to hook up the screen. Let's follow this scheme. I'm gonna mash up the pins a little because I prefer matching numbers, and also I want them all near each other. I'm going to wire it up just like in the scheme, apart from RS that is connected to D2, E that is connected to D3, D4 that is connected to D4, and so on and so forth. Now that the circuit is assembled, we need to work on the code. I've opened a new file in the Arduino IDE, and I simply copy and paste the code from the tutorial I've showed you before. I'll define all the pins I'm going to use in case I want to change them later. I'm going to add a set cursor before the print because I want the screen to show a nice hello in its center. Let's see if it compiles. Oops, I forgot an LCD. Now it should work. Okay, the screen is on, so it is powered. Done uploading. We can't see anything, but probably we had to mess up with the potentiometer. Okay, this should be fine. Okay, fine, it's working. Now, the screen is working, good. But we don't want it to be always on because our device is going to work on batteries. So we need to learn how to switch the LCD off. There is no function to turn the screen off, so we must power it off. We are going to use a transistor to disconnect the screen from the ground. The first of its like will be connected to a pin of the Arduino, the second to all the pins of the screen which should be connected to the ground, and the third to the ground. I've connected the transistor to the A7 pin of the Arduino. I'll use it because a lot of digital pins need to be free for later. I've read a switch on function to set the pin voltage high and then do what our old setup function did. I insert a delay in the middle to make sure everything's settled when I initialize the screen. I declare the pin as an output because I'll use it to tell the transistor whether to let the current pass or not. Now I've read a switch off function. First, I need to declare all the pins connected to the screen as inputs to optimize power consumption. Once again, I insert a delay to let things settle, and then I set the A7 pin voltage to low. I'll insert a boolean to make sure I don't switch on an already on screen or switch off an already off screen. Now I can test my functions. In the loop, I'll make the screen power on and off every 2 seconds.
It's on.
Suspicious, this screen is still always on.
I just noticed that I didn't connect this ground to the transistor, so I do it now.
Now it should work. Let's hope so. It is on, off, on. Yes, it's working. Now that the screen is working, I'm going to test the LEDs and the phototransistor. I'm going to use a strip of addressable LEDs, a power brick, the breadboard with the Arduino Nano, and the proximity sensor. The proximity sensor is composed by a LED and a phototransistor. The LED is the clear one. Since I'm not sure which is its positive and which is its negative terminal, I'm using a multimeter to check. The current should pass only in the right direction. So we have the negative to the left and the positive to the right. For the photodetector, I'll just have to try. Let's hook up the proximity sensor. Both the negative terminal of the LED and the terminal of the phototransistor we assume to be negative will be connected to ground, while the other terminals will be connected to one pin of the Arduino. The positive terminal of the photodetector will be connected to the 5 volts through a resistor, so we can measure the voltage drop on it using an analog pin of the Arduino. Now I just want to verify whether I wired the phototransistor correctly. I'll read its value through the analog pin I've connected to its positive terminal. It should let more current pass the more infrared light it can sense. Less current means a lower voltage drop on the resistor connected to the 5 volts, so we should measure a higher voltage if I cover it with my hand.
I've uploaded the code on the board. Let's see if it works. Okay, so it's printing something, but it's not changing so much when I pass my hand. So I'll try to turn the photodetector in the opposite way. Let's see if it works better this way. Much better.
Now I'm going to use the proximity sensor properly. Basically, I'm going to measure the percent difference between the light the phototransistor measures when the LED is off and the light it measures when the LED is on. If there aren't obstacles over the sensor, the difference should be quite low. Otherwise, when the LED is on, its light is going to be reflected by the obstacles to the photodetector, and the difference between the two lights we measure should increase.
Now we should see the percent difference of the two lights we are measuring. Oops. Okay, I could have printed a space, but I guess you can see that the value is 0.13. Now, when I put my hand on, it raises a lot to 0.87.
My goal is to see whether a hand passes over the sensor, and that's why my movement function returns a boolean. I've measured two values, 0.13 if the sensor is free, 0.87 if my hand is over the sensor, so I think a good threshold to determine if the sensor is covered could be their mean, 0.5. If the percent difference of the lights I measure is lower than 0.5, movement will return false, and I'll print free at screen. Otherwise, movement will return true, and I'll print covered.
I've uploaded the new code on the board. Now it's printing free. Let's see with my hand. Correct. Free. Correct. Free. Okay.
I'll take advantage of this code to test the LEDs too. I'm going to use the fast LED library, and my objective will be having just one switched on LED that moves forward one step every time I pass my hand on the sensor. Here I power both the LEDs and the Arduino with the power bank, and 1, 2, 3, yay! Now it's time to see how I can use buttons through a multiplexer, because I've never done it. So as a first thing, I'm going to solder these pins to the multiplexer to easily plug in and out the cables from this part. Okay, the soldering iron is already out, so not my best work, but that should do. Now I'm going to solder these two buttons just for tests, and I've prepared some wires that I will use.
Two hours later.
As you could probably understand from the video, I'm not the most skilled solderer, and I could not work on the best soldering settings right now, but here we are, and they seem to work. I will connect the signal pin of the multiplexer to pin A4 of the Arduino, and the address lines S0 to S3 to pins D9 to D12. Then VCC to 5 volts, ground to ground, and enable to ground. Okay, so I need one signal pin that will read the button and 4 pins that will tell the multiplexer which button to read. And then I'm going to print at screen the number of the button I've pressed. I've just uploaded the code on the board, and now I want to see if the buttons are working. So this one prints 0, this one prints 1, 0, 1. Done. For the main code, I've copied all the includes and the defines of the other files here in the main tab, while I've copied the functions in the other tabs. I've added just 2 tabs to manage the dates and the LEDs, but they are really simple and they are just used to read and save the dates, or to lighten up the LEDs with different colors. So the main changes starts here. So at the end of the setup, the LCD is switched on, and then the function asks for the actual time, because you need to know what time is it to compare it to the food expired dates. And in the loop, if the screen is on and a lot of time is passed, it is switched off, then all the buttons are checked. You can reset the entry by pressing the button for a long time, or just press for a short time to see or edit the date. Otherwise, if the LCD is switched off and the photosensor perceives a movement, the screen is switched on. I've cut 2 pieces of cardboard with this dimension, which is like 3 centimeters over every border of the whiteboard, apart from one that is like 5 centimeters. And I've cut this one to let the whiteboard and the LEDs come out like this. Okay. And now I will cut all the places for the buttons. And ta-da! I have got all the buttons.
Now we need to color the pieces of cardboard. I've added a hole for the screen and one for the photo detector. Okay. Okay, I think I'll ask the help of my boyfriend. Oh, now it's open.
So this is the situation right now. I put the buttons once again in, and the photo detector and the screen, and I've soldered all the buttons like I did in the test phase. I also added 2 paper bands on the LED to smooth them. Let's pass to the alimentation part. Here I have a micro USB charger that is already soldered to a battery, and I'm going to connect it to a step-up module using even a switch so I can power off the Smartboard.
Is a quick update. I've glued with hot glue some parts like the battery and the micro USB charger, and now I'm about to solder the ground pole of the buttons together. I've soldered everything together, and now my boyfriend is checking my job to make sure I don't make myself explode.
So that's it. And as you can see, we already entered some entries. And now I'm going to show how to use it from the start. So every time the Arduino is switched off, then you need to turn it on. I'm using a power bank right now to power it. Okay, so it says hello and it asks you for the time. So it's 22:02. Okay, so okay, hours 22 is the 15th May 2020. Okay, so the time is set as you can see, the cheese is going to last for a long time, while the tomatoes needs to be eaten by 3 days and the apples by 5 days. What if we want to add a new food? Wave in front of the sensor, press the button, write the entry, insert the date. Let's see if we insert tomorrow as the date. So, 16th of May 2020. Save. Look at it, it's red, it's about to expire. By the way, it doesn't work so bad. See? I hope you liked the video and that this project can be useful for you too. And if that is the case, you can find the code that I have put in the Arduino on element 14. And what about you? Have you any special ideas to remind you about food that is about to expire? And maybe you can actually use it and improve it with a smart and cool 3D printed core. Bye!